individuation or individuality, if you like, of individuals. And I will discuss a particular theory of types and a number of applications. And in particular, one, given the topic, the theme of the event, arte artificio, one application of computational creativity or computational art, but more on computational creativity in the end, which relies heavily on this theory of types. So again, I'm a full professor here in Bolzano, and also a full professor in the Netherlands, in the University of Twente in the Netherlands. So this is about artificial intelligence as well. And let's say the modern discussion on artificial intelligence seems to be a reenactment of the old philosophical discussion between empiricism on one hand and nativism on the other hand. I prefer to frame this as a discussion between left brain and right brain type of processing. So now, in the first wave of AI, we had a very strong focus on left brain type of reasoning, so symbolic reasoning, and now a very, maybe an obsession on this kind of a right brain type of processing, on numerical processing, on processing that tries to rely exclusively on data, and try to reconstruct everything out of sense data, in a sense, finding patterns and so on, and tries as much as possible to dispense with concepts. Let me just say, okay, thank you. There's a door that keeps opening here. Grazie. So I will, in this particular topic of types and identity, I will start with this exercise of coming up with, starting with a theory of concepts that tries to dispense with symbols, with symbolic reasoning, and see how far we can go. And, you know, spoiler alert, we're going to conclude that this is not enough. And you should suspect, right? Because, you know, evolution would get rid of half of your brain if you could dispense with it. You know, the brain is very expensive. It consumes 25% of all your energy. So we would have just a pattern matching and this kind of right brain processing if we could. So I will start with this theory that tries to assume a minimal structure and tries to reconstruct types and identity from this. And then, since we're not going to be able to do that, I will come up with a different theory and then show a number of applications. And one of the applications will be the reconciliation of these two theories, or a kind of hybrid reasoning that will combine symbolic with geometrical numerical processing. And then I will show two other applications. One which is related to integration and interoperability of data and applications, what is called semantic interoperability. And the third one, which is related to computational creativity. So here's the theory that tries to provide some structure, but a minimal structure over this sea of patterns or of sense data. And this is a geometric view on types. And this is the theory put forth by the Swedish philosopher and cognitive science, Peter Gärdenfors, in this beautiful book called The Conceptual Spaces, The Geometry of Thought. Again, in a literal sense, tries to provide a theory, geometrical theory of concepts and individuals and reasoning. Also here in this more recent book in the Synthese library, which is called Conceptual Space, Elaboration and Applications. Actually, the first part of this talk is published in the second book. If people are interested, I'm happy to share the paper. I'm a big fan of Gärdenfors' theory. I think it can do a number of interesting things. Unfortunately, it cannot solve this particular problem we are discussing today by itself. So what is the theory in a nutshell? This idea that for all properties of things, we have associated in human cognition certain geometric structures, literally some spaces with some topological and geometrical structures. So for example, for things like height and weight, we have associated this linear structure, which is isomorphic to the positive half-line of real numbers. And these dimensions, which he calls quality dimensions, sometimes they are codependent. They are mutually codependent. And then they form what is called the quality domain. And you know, a stereotypical example is the color domain or the color spindle, in which you have these two linear dimensions of saturation and brightness, and a polar dimension of hue, right? What is called the color circle. And these things are mutually dependent. So every perception of color would be a perception, a point in this three-dimensional space. And there are constraints over these dimensions. Like, for example, if saturation gets too low, you cannot see any difference in hue anymore. Or if brightness gets too high, everything collapses to white, and you do not see any difference in saturation or hue, and so on. And the idea here is that properties in garden force theory are grounded on these geometrical spaces by defining convex regions. So you have a space, a metric space with some sort of distance, therefore, and then you can use this distance to create these convex regions in space, and then you can explain what red is. So red would be a convex region, for example, in this color spindle. And then you can associate these domains. So domains are, let's say, collections, structures with codependent dimensions. And you can have spaces which are compositions of several independent domains, right? So here we have the space of apple, which will be a combination of, the space of color, the space of texture, the space of taste, which is a tetrahedron, right? Four-dimensional space, and so on, right? And Jardenforce used this to differentiate also properties and categories, right? So categories are things, are concepts which are grounded in these conceptual spaces, which are composed of independent domains. Individuals in this theory would be a point, basically a vector in this multidimensional space, right? So if you have one dimension, one point is a particular weight. If you have this multidimensional apple space, for example, one point is a vector in this multidimensional space or spaces. It can deal with a number of interesting problems. So it provides some sort of symbol grounding, for example, for explaining what is an individual. I just did that. So an individual is basically a vector in this multidimensional space. And a type would be a region. A property would be a region in one color, one quality dimension or a quality domain. And a category would be a region, a convex region in this conceptual space, right? So here we have an individual. We know that this individual is an instance of that type, the green type, whatever green means here. And we can reason with subsumption, for example, very easily as well. So for example, we can have, am I still here? Seems that I got disconnected. So I'm assuming not. So we can reason with subsumption. For example, we know that all greens are blue. So if this dot here, this individual is an instance of green, it's also an instance of blue, right? And this is what is called a principle of application. So it's a principle of application is a principle with which we can judge if something is an instance of a particular type. And all types would have this principle of application. So how can I decide if a particular individual is an instance of a particular type? It also provides grounding for meta properties of properties, for example. So if I have a binary or a relational property, like being heavier than, I can explain that X is heavier than Y because the weight of X is is greater than the weight of y. And I can also explain why heavier than is a total order relation. It's because it's grounded on a quality dimension which is totally order, which is this positive half line of real numbers that I mentioned before. What else can it do? It can provide some sort of connection between the subsymbolic world in which you just have symbols, in which you just have sense data, numbers, and the symbolic world in the way that I just did, right? So it explains what red, the predicate is. It corresponds to a convex region in this particular space, and this connects to a space of possible numbers. In fact, I can generate properties in this way by just having a number of prototypes, right? So I have a space, whatever space here is two-dimensional, but it could be n-dimensional. I can generate a number of properties just by taking a number of prototypes and creating a Voronoi tessellation by using a distance function. I can even do better than that. I can create sets of prototypes and create a number of different Voronoi tessellations, what is called a collated Voronoi tessellation, right? And then I can use this to explain, for example, the fuzzy membership of an individual in a class, right? So given all the possible Voronoi tessellations, the degree of redness, for example, of C would be the proportion of the number of these Voronoi tessellations that would put C in the red region, right? And this is a much better explanation for fuzzy numbers than anything else that I'm aware of. It also explains one interesting problem, which is the difference between genuine types and properties on one hand, and mere logical predicates on the other hand. What philosophers, for example, the philosopher David Lewis, would call the difference between natural and abundant attributions. So let me show you the problem. So the problem you have if you equate logical predicates with, let's say, ontological properties, right? So imagine that C here is it's a type, which are the things that conduct electricity, for example, and A is an instance of C. So the idea with instantiation or predication here is that this A should have some positive genuine properties or causal powers because it's an instance of that type, right? I can have another type here, which is the type M, let's say the types of things that can move in space, and B is an instance of M. And I have yet another type here, which is the type F, which, let's say, things that catch on fire in contact with air, right? The problem with equating properties and predicates is that I can do things like that with predicates, right? So I can magically create another type P, which is the disjunction of C and M. And this would make both A and B instance of P magically. But this is very strange because there are no new powers, no new genuine properties acquired by A and B just in virtue of instantiating P. In fact, there is nothing common at all, which contradicts this idea that types, genuine types, should describe things which are common across multiple instances. It's repeatable across multiple instances. Likewise, I could create a type here, Q, which is just the negation of C, right? And this would magically make both B and C instance of Q. And again, they have nothing in common, and there is nothing they can do now that they couldn't do before. So one thing that conceptual space can do that, explain the difference between natural and abundant attributions, because natural attributions would correspond to convex regions, as opposed to these negative properties or negative predicates or disjunctive predicates. So it can do a lot. It can go quite far, right? But one thing it cannot do is to, for example, explain what is the relation between two individuals that have incompatible properties, but which are still, in a sense, the same individual. So how to distinguish two individuals to explain this model behavior of an entity changing its properties, but still being the same. So how to identify, re-identify individuals diachronically. Also explain that the one individual can move out of a certain region and move back to a region. For example, I can cease to be a professor. So if there is a region for professors, I could move in and out of this region, and I'll still maintain my identity. Or I was once a student and I was in the student region in that space, and I moved out and I'm still the same individual. It also cannot explain how to distinguish two individuals which are qualitatively identical. So imagine a certain point in time, I have the exact same properties as someone else. We would converge into the same point in this space, but we would be different individuals, or we should be regarded as different individuals. So, to illustrate this point, imagine John is here. John is these two different points. Although they are qualitatively different, they are two representations of the very same individual, the very same 4D individual, if you like, who's John. And John, if the black dot is also John, it means that being an instance of this green thing is not essential, necessary, modally necessary for John. And we do that all the time, right? We would like to say that this individual here, who's an instance of senior citizen, is identical to this individual here, who's an instance of boy, right? Although, to quote the philosopher John Perry, the first is not a boy and the second is not, the latter is not a senior citizen, but they are identical. They're also identical to these other individuals here, the singer on the left and the actor on the right? So this same entity can move into different spaces, in and out of these different spaces, and maintain identity. We can even do counterfactual reasoning and imagine other possible spaces and say, for example, what if this individual, Mick Jagger, had dropped out of the London School of Economics and he would nowadays be an economist, and who would be identical to this actual singer, right? We can do that because there is something here which provides this principle of cross-world identity, which is not singer, which is not economist or actor or senior citizen or boy, but it's a type that this individual instantiates necessarily, and that provides this principle of identity, of individuation, and of persistence. Tells us that because in this case, the type is the type person, right? Because Mick Jagger is a person, we know in a kind of a prioristic way what kind of changes can Mick Jagger undergo and still be the same individual. Let's do another thought experiment. Imagine if I have this statue of Mick Jagger now, and I take this statue and I just make it a blob, right? So I deform the statue and I create this blob out of the clay from which the statue was made. So the question is, is the thing on the right the same as the thing on the left? Well, it depends what is the kind instantiated by the thing on the right and the thing on the left, right? And I'm using kind technically here. So kind is this type that provides this type that entities instantiate in all possible situations. So the instance of that type instantiates that type in all possible situations, because the principle of identity should be used to judge identity in all possible situations. And that provides this principle of identity, individuation, and persistence, and so on. Things can only instantiate one kind and one unique kind. Otherwise, you get into contradictions. So, for example, if the thing here on the right and the thing on the left are both instances of statue, I have a determinate answer. The thing on the right is not identical to the thing on the left because the shape is an essential property for statues. However, if they are both instances of the type lump of clay, being shaped like Mick Jagger is just an accidental or contingent property for the lump of clay. So the individual can survive the change in that property and still be the same individual. It's the same lump of clay, contingently shaped as Mick Jagger and contingently shaped as a ball, as a blob. So all types have a principle of application, the principle with which we can judge if something is an instance of that type, but only certain types have principles of identity, these principles of diachronic or cross-world identity. Can we capture principles of application and identity in conceptual space? Not really. So principles of application is quite easy, as we discussed before. So it's judging if something is a vector in that space. And in fact, judging if, for example, if the thing on the right is gray or round, we just need to look at that thing in one possible situation, in one particular situation, right? It's just that thing. Would that thing map to that gray zone in one of its qualities? Would it map to the round shape space with its shape quality? That would suffice to answer this question, if that is an instance of gray or round and so on. But conceptual spaces, as we've seen, cannot give us this cross-world principle of identity. In fact, we could, even if we include a kind of time dimension, right, and we make individuals in conceptual spaces not points but lines or traces, we still have to explain what kind of points can be part of a particular trace. And I hope to have made the case that we can only answer that with the support of this kind, right? If we don't have a kind person to tell you what kind of points can be part of a line or a trace of an instance of person, so people cannot, for example, get completely detached parts, cannot survive a piano falling on top of them and becoming a mass and stuff like that, right? It's the type that gives us the answer. In a kind of a prioristic way, what kind of points can be part of lines or traces of instance of people, right? And again, spatial temporal continuity won't do, because my example of the piano falling on top of a person or of a statue, to be less tragic, would maintain spatial temporal continuity. So we need a theory of types that takes that into account in a very, very explicit way. So let's start with, just to illustrate this, so we've just seen very fundamental distinctions between types that provide just a principle of application and types which provide a principle of application and a principle of identity. And, this is coded in language. So if we have, because it's coded in cognition, right? So imagine if we have this sentence like this: there were exactly 5 mice in the kitchen last night, or the mouse that ate the cheese is the one that has been eaten by the cat. We can only replace mice here in this sentence by another common noun, right? If we do, so X here in these patterns can only be replaced by a common noun. Otherwise, we get ungrammatical sentences, right? We cannot say there were exactly 5 reds in the kitchen last night, or the red that ate the cheese is the one that has been eaten by the cat, because the only way to make this sentence grammatical is if we nominalize red, and we use red is either as a, as a metaphor for communists, let's say, or we use red as shades of red. In both cases, they are common nouns, right? And the reason is because in the first sentence, in order to do that, we need the principle of counting. And counting requires identity. So to say that there were exactly 5 something, I must be able to individuate and identify things, because counting requires individuation and requires identity, so that I know that I'm not counting the same thing several times. And the second one, it's an explicit reference to identity. So I have to be able to re-identify the thing that ate the cheese as the same as the one being eaten by the cat. So sentence like that would require this principle of individuation and identity. And that's why they require grammatically a common noun, because common nouns are the linguistic counterparts of a particular type of type. This is also quite well known in knowledge representation. So this is an example from my good friend Nicola Guarino. His point is, if we are in a logical level, everything is in the same logical footing, both being an apple and being red would be identical. There would be unary predicates. They would be in the same logical footing, not identical. And we would write something like this, saying that there are red apples. We would write a formula like this. There are X, such that X is apple and red, and they're both unary predicates. However, if we were to structure this by choosing one of these things to be a type or a category, and the other thing to be a property, which is something we've been doing since the end of the 60s with Ross Quillian and his proposal of semantic networks, we would need to choose between these two structural choices, right? We could say there are apples, some of which have the property of being red, or alternatively, we can say there are red things, some of which have the property of being an apple. And I bet that, forced to choose, every one of you would choose the structure on the left. However, semantic networks or this structuring language themselves, they cannot provide an explanation for why the structure on the left is better than the structure on the right. And it's because this explanation is outside this epistemological level, is in what Nicola calls an ontological level. Because the distinction here is an ontological one between these two different types of types. Sortals, these types which can provide also a principle of individuation, identity, persistence, which are reflecting language as common nouns, and non-sortals, which are types that classify things identified by principles of different sortals. For example, red. So what we need is a theory that honors that makes justice to this diversity of types, or meta-types. So we start with this distinction between non-sortals, sometimes called characterizing types, because they characterize things which have been identified by things of multiple kinds. The term comes from the philosopher Peter Strawson, or sortals that supply these principles of application, identity, individuation, and persistence. I already mentioned the word kind, which is this strong type that provides all the essential properties for the individuals it collects. And this is a type that entities instantiate necessarily in a model sense, but specializing subsumed by kind, we have other sortals that inherit the principle of identity supplied by kind, but which are dynamic, which are contingent. So for example, as I mentioned before, I'm necessarily a person, but I'm contingently a professor or an adult man. I was once a teenager, once a kid. I was once a student. I can move in and out of these spaces and still be the same individual. Like, for example, a lepidopteron is necessarily a lepidopteron, but it's contingently a caterpillar or a butterfly. Like a city is necessarily a city, but it's only contingently a metropolis after its population grows over a certain size and the city grows in complexity, and so on. So here we have a typology of types, right? The distinction between sortals and non-sortals. And within sortals, kinds, and what is called a phase sortal by the philosopher David Wiggins. And within phase sortals, we can go one step further and distinguish between what are called phases. So types, which are dynamic, but which dynamic classification condition is an intrinsic one. So I become an adult because something intrinsic changed in me, while we have other phase sortals called roles that the dynamic classification conditional is a relational one. So in order to be a father, I need to have an offspring, and in order to be a husband, I need to have a spouse, and in order to be an employee, I need to have an employment relation with some education, with some employer, right? And we can think about these things again in different types of geometric space. So imagine everything which exists in my universe here, and this universe would be tessellated by kinds, right? Because everything belongs to one kind, one unique kind, and the boundaries of these partitions, of the segments, are rigid. So things cannot move in and out of kinds. So things cannot change kinds, bear, transubstantiation and things like that. So suppose K2 is the type person and K1 is the type car, and the K3 is the kind organization. Cars cannot become organizations, and organizations cannot become people, and so on. So things cannot move in and out of these kinds, and things belong to one kind and one unique kind. So a tessellation of the space of individuals. While the space sortals are like shadows moving in and out of moving in the space confined within a given kind, but moving and classifying and declassifying instance of those kinds. What kind of applications we have with this theory? So the first one is a kind of hybrid reasoning by combining this with the geometric reason we have provided by conceptual spaces. And in this case, we would have a way of reasoning that would honor both the principle of application and the principle of identity, right? So imagine if we have the former type of spaces, garden Fordycean spaces here in the bottom of the slides, and we have these new spaces that I have just shown you on the top of the slide, right? So we have this two space, a kind of hyperspace, and the space on top, we have individuals, or what Leibniz called the individual concepts, or we can think of this as functions from worlds, from situations to points or vectors in the lower space. So suppose K2 is a person, and you know, the individual here from which there are arrows outgoing is myself, or Mick Jagger. And in different worlds, the proper name or the individual concept Mick Jagger would point to a given point in this lower space, and the trajectory or the trace, even a kind of traces, branching traces in different possible worlds, would map different states of Mick Jagger. But the possible vectors that can constitute the things that traces of that kind, of the kind person, is given by the meaning or the principle of identity provided by the kind person itself. So the top space provides constraints over these functions, right? These proper name functions, these individual concept functions, that selects what kind of things can be pointed by those functions, and therefore selects what kind of vectors can represent states, snapshot states of things of the kind person. One interesting thing that we can have here is that if we look at the lower space, suppose that region there is the region in which we have these 3 points, is the property of being red, right? And we have things of different kinds that can have states in that region. This could help us to explain why a non-sortal is a type of type which cross-cut several regions, which one of the definitions of non-sortal. So this type that collects or classify instances of multiple kinds. And this is not just red, but it is, for example, customer, which can be people and organization, for example. So what we did was actually to propose this system of logics that honors this distinction. So a kind of sortal logics. All variables are bound to a sortal. And we have two different domains of quantification. So the interpretation of instances of sortals would point to sets of individual concepts, functions from worlds to vectors. And in the interpretation of non-sortals, of characterizing types like reds and rounds and things like that, and things that conduct electricity, for example, or things which are cultural heritage items that would include both Mick Jagger and buildings and events and food and stuff like that, event types and food. The interpretation of those types would be vectors in a garden Fordycean type of space. So we have a logics with multiple domains of interpretation, and sortals are mapped to this domain of individual concepts, which can trace the identity of those vectors representing states of 3D or 4D individuals like myself in different possible worlds. Okay, so this is one application. If people are interested, again, I'm happy to share the publications related to this. Another application is this one of semantic interoperability. And what is semantic interoperability? If we take any an information system makes an ontological commitment, commits to a given worldview, to the existence of a number of things with certain properties, certain behavior, certain relations, and so on. So for example, even if we take a very mundane database about transplants, this database, let's say, commits to the existence of people who could be living or deceased, transplants, and people that participate in these transplants as surgeons or donors and donees and so on, right? And that in order to be a donee, you have to receive an organ from the donor in a transplant which is performed by a surgeon and so on. The problem is all the interesting questions we need to have answered as in government, in science, and in organization can only be answered if we put together data which now reside in this autonomously, concurrently developed data silos, right? So in order to answer these questions, we have to put data from different information systems or different database developed by different people in different points in time. And how can we do that? In order to do that, we have to somehow relate these different ontologies which are embedded in these different information systems or database. So if we want to integrate two databases which we talk about transplants, we need to somehow, we're going to find transplant on the database on the left and transplant on the database on the right. And we have to find out what is the relation between these two things. I mean, we cannot assume this is a relation of identity between types just because we are using the same lexical label to refer to them. I mean, it might be identity, but it might be, specialization or dependence, different types of dependence and so on. So we have to find maybe historical dependence and things like that, right? Instantiation. So we have to find out what is this relation between the two things or between people. And we think, this is trivial. Of course, people on the left is identical to people on the right. I'm talking about identity of types now. Not so fast. So when we mention person, and I have seen this so many times because it's one of my main areas of application, that in every single domain that you look, if you put together different database or different applications, you're going to get this. You're going to get the same concept. So different concepts represented by the same term in different applications in ways that are related, so kind of systematic polysemy, but which relation is not obvious. So by person, we mean human being. Do we mean cognitively capable human being in the sense that if you are brain dead, you are not a legal person anymore, or a legally recognized human being, which will be similar to a different conception of legal person that is close to the conception of being a citizen, right? That you are recognized by state as a legal person. Well, here we can easily differentiate these three things with the vocabulary and the toolbox that we just discussed. Being a human being is a kind of thing. Being a cognitively capable human being is a phase of things. So if I'm brain dead, if I suffer some cognitive accident or brain and neurological accident, I'm not a cognitively capable person anymore, and therefore not a person in the second sense. And in order for me to be recognized as a human being, I need to be recognized by a certain state, which means that this is a relational property as well, and it's a contingent one, and therefore a role. And if I have a language or a representation mechanism that marks the distinction here between kinds and phases and roles, I can easily see in these different information systems that although person, that I use the term person on the left, on the right, that they are different things because they are instances of different metatypes. In fact, here, the concept of human being would be identical to the concept of person on the left, and therefore the concept of person on the right is actually a specialization of the type person on the left. Now, the third application, computational creativity. And since we don't have much time, I will focus on one very specific thing, which is this idea of how can computers create new types or new concepts, right? And here I'm using this theory of what is called conceptual blending, put forth by Mark Turner and Gilles Fauconnier. And this is a work done in my group in Bolzano by several people, but mainly Oliver Kutz, who's leading this. And the idea here is that you have conceptual spaces and you want to create a new type by fusing, by blending properties from different spaces. And here you have a kind of generic space that explains the selection of the properties on the original spaces, which one you are taking from each of the spaces, right? So you abstract and explain this connection and selection. And then you have a blended space, which is a space that of new concepts, right? So one example is, suppose you have the concept of mother and you have the concept of ship, and you understand that both ships and mothers can bear this relation of containment with things of the same kind, and then you can use this abstraction to create a new concept, which is the concept of mothership. And we wrote a paper exploring this idea using superheroes. Superheroes are very interesting because they are all blended, right? So we wanted to explain, so here again in this example, we have a source domain like the space of man here in description logics that describes property like being, a male, biped, having a humanoid shape, and so on. And we have the space of spider, which are these things, that can crawl, climb on the wall, they can inject venom, they have 8 legs, they can eat flies and stuff like that, and they are malicious in a sense. And we want you to explain why the blending of these things would create something like Spider-Man, right? Which explain what is behind in the generic space of the particular selection that we take in the true space to the blending. Or if we have, the Black Panther, same thing, right? The space of man, space of panther, and we do this particular fusing. But not one. I mean, why don't we have Spider-Man as this strange thing with a arachnoid shape and eating flies and, let's say puking, melting acid and stuff like that, right? Why don't we have this? So what would explain a particular selection as opposed to another selection? So there are two problems. One problem is which I want to have the chance to delve into, which is this use of values as a way to inform the selection. But there is another problem, which is the problem with an ontological problem, which is the following. If I have these two spaces, man and spider, these are two kinds, and we saw that something can only be an instance of one kind, right? So if we had Spider-Man being both a man and a spider, this would not be a consistent individual because man and spider provide different principles of identity. And if something had happened to Peter Parker, maybe he would not be a man anymore, but it would still be a spider. We're going to get this strange contradiction. So Peter Parker cannot be both an instance of man and spider. So what we do in this paper is to explain that every time you have this conceptual blending, what we have is a collision between types, and one of these types get deprecated to a non-sortal by a kind of value selection function, right? So what we have here is that instead of spider, we abstract or refactor this non-sortal type, which is arachnoid entity, which can be instantiated by things of multiple kinds, like spiders, necessarily in the case of spiders, but contingently for the case of men, which acquire arachnoid properties. So Peter Parker here is an instance of man. Necessarily, he's been a man all along, and he's still a man. He has psychological continuity, for example, with all his man-like properties, and he has empathy, and he has all human values and so on. But he acquires these properties, which are properties that can be ascribed to things of multiple kinds, both man and spider in this fictitious universe. So he is contingently an instance of arachnoidentity and an instance of this non-sortotype arachnoidentity by having some spider-like properties, but still an instance of man and obeying the properties of the kind man and the principle of identity of the kind man. And this is a theory that we need in order to help computers to create new types and do this kind of conceptual blending in a way that honors, again, both the principle of application and the principle of identity. So Spider-Man is a man. Spider-Man, the type, is the phase of entities of the kind man. That's all for today. Thank you very much for your attention, and grazie a voi.
Grazie Giancarlo, grazie. Bene, quindi noi ora abbiamo mezz'ora di